in some situations, it is not feasible to develop a theoretical model due to several factors such as lack of information, modeling complexity, and even engineering effort is required. Let's say we are given a simple RC circuit like this, and we can apply the V in and we can observe the V out. We can actually get the simple equation to represent this circuit, which V out is equivalent to a function of V in. It's very simple because we can see the R, we can see the capacitor, we know the connection, so we definitely can derive the equation out of this circuit. So this circuit is definitely easily be modeled. What if we have another circuit which is slightly complicated as compared to the previous one? So once we look at the circuit, we can do some derivation, and of course we can write what is the output of V out in terms of the V in. So this is possible because we can see the connection, the inside of the system. So definitely this circuit can be modeled without using any empirical approach, because we can simply derive this mathematical equation by observing the electronic circuit inside the circuit. But what if the internal circuit is not available? We only know that this is the input that affect the output, and we can measure the output which changes as we change the input, but we cannot see the inside circuit. So how possible for us to write the equation to represent this electronic circuit? So definitely it is no. Therefore, in this scenario, without knowing without having the information inside the circuit, we definitely have to go for empirical modeling. So developing an empirical modeling is the alternative to solve the modeling approach for this kind of system. So we will go further and explore about empirical modeling. And definitely the empirical modeling has its own advantage and disadvantage. The advantage is less effort is required, no complicated modeling or mathematical approach will be used. It's very simple and fast. The disadvantage is the model is only valid for the range data used in its development, meaning that the empirical model usually don't extrapolate very well. So if we do the empirical modeling for a range, for example, between 50 degrees Celsius until 100 degrees Celsius, then the model can represent the behavior quite accurately between this range. But if we are going to evaluate or simulate what will happen beyond the modeling range, let's say we want to look at the behavior between 120 and 130, which is beyond the modeling range, definitely the result won't be valid and in most cases not accurate.